Now, as I said, it may be that we are using multiple threads to actually work on the same resource. Just like my normal cooking example which I'm giving, that if we have multiple cooks working on the same dish, we really need to make sure that the cooks have synchronism in between them, they are synchronized, so that our dish comes out perfect. If the cooks are not synchronized, if cooks are just doing haphazardly things to the dish, it would definitely not turn out as we expect, right? So let's say if we are really making tea and we really are using 3 cooks, which may be an overkill in our situation, right? For making tea, we don't need 3 cooks. We can make tea by just using 1 cook, right? But then let's say, for example, we are making a very elaborate dish, but to simplify concept, I'm taking an example of tea. We really need to make sure that, the first cook is actually, putting water on the stove, and then, the other cook is putting tea leaves, and then, the third cook might put other garnishing items like sugar or ginger or, cardamom or anything else, right? What if before even putting water, you start putting tea leaves or other things? They would get burnt just because, the stove is on, right? So you don't want this kind of, non-synchronized efforts. You want synchronized efforts from the threads. And that's exactly what we want to achieve using synchronization. So synchronization gives us the ability to control the access of multiple threads to any shared resource. It allows us that, only one thread is able to access the shared resource at a single time. And we really want to use the synchronized keyword of Java to make sure that is happening. For example, at the same time, when the water is being poured, you don't want to pour tea leaves. It may cause, some accidents. It may cause some issues. And similarly, we don't want to work on the shared resource by multiple thread at the same time. We really want to synchronize their efforts. We use the synchronized keyword for that. This synchronized keyword would really help us prevent any thread interference of other threads happening to the common shared resource. And it would definitely prevent any consistency problem which we have. For example, if multiple threads are actually writing to a single file, we really want one thread to complete writing to the file before any other thread starts writing to the file. Or let's say, for example, we are actually printing certain things using the printer. You don't want the operating system to allow multiple programs to print onto the same page, because then you have something wrong happening on the page, right? You may be writing something and then suddenly the other program is writing something else, and you have a total mess on the printed paper. You don't want that. You really want the shared resource to be used and done with by one thread before going on to the other thread. And we use synchronization for that. Now, synchronization would make our threads mutually exclusive. So there's no dependency between, multiple threads. We really want our threads to be mutually exclusive. And it really helps, with all the inter-thread communication as well. So to make a particular shared resource or a number of lines of code mutually exclusive, we have 3 methods. We could use the synchronized method, meaning we use the synchronized word with a particular method, or we use a synchronized block, meaning we use the synchronized keyword for a small block. We don't have to actually use it for the entire method completely, or we use static synchronization. These are the things which we are going to see now. And this really helps us, have this whole cooperation between multiple threads, which we call inter-thread communication as well. Now, to demonstrate this thread synchronization, I'm actually going to create a new class for thread synchronization. It's going to be called thread synchronization. And within this, I'm actually going to create a new method, and this is just going to generate a simple string for us. I'm going to call it generate string. And I just want to generate a particular pattern, and I really want to make sure that my pattern is always consistent. My pattern should not have any issues. So for example, I would just, simply have a loop in this for I equal to 0, I less than 10, I plus plus. And in this, I want to make sure that, if, for example, my I is less than 5, I want to print, let's say, a star. Else, once it gets greater than 5, then I want to print a hash. And yeah, once this thing is over, then I want to just print out a new line. So this is what my generate method would do. Let me just format it a bit. Once my generate string method is created, then I actually want to call this particular generate string from multiple threads which I would want to create. So let's actually create a new class, in which I would have this worker, and this class worker is going to have my entire generate method. Now within this thread synchronization class, what I would do is I would create my main method, because that's where my program is going to begin. And in this, I'm actually going to create a new object of this worker class. So I would write worker w1 equal to new worker. And now I'm actually going to just, create a new anonymous thread. And within this, I'm going to create a new runnable method over here. And within my new runnable, I'm actually going to override, as usual, my run method. Now within run, I actually want to generate this, star and hash symbols for a couple of times. So what I'll do is, again, have my for loop, for int I equal to 0, I less than 5, let's say, and what I'll do is I++, and then I'm going to actually call w1 dot generate string. This is something which I want to do in this particular thread. And then I'm going to simply start the thread. Now I'll save this. And now we really want to work on thread synchronization, right? So we need to have multiple threads. So what I'll do is I'll actually copy this entire thing again. So we actually have 2 threads now. We have the first thread running for, 5 times and generating the string, another thread running for 5 times and generating the string. Now let's try to actually run this program and see what happens in our console. So now when I have actually run this, you would see that there is some inconsistency happening over here. Sometimes the stars are coming ahead, sometimes, they are coming at the end as well. Sometimes we only have hashes. And every time I run this, I get a different pattern. This is not what I want. I want a consistent pattern, right? And the reason for this is because both the threads are actually working at the same time. And this is how threads work, right? They actually work at the same time. As soon as they get some time from the CPU, they run. And if I really want to generate this string properly, the way I want, initially all stars, then all hashes, and then a new line. If I really want to make sure that my threads are not working on this common method, this common resource in a haphazard manner, I really want it to be synchronized. And the simple way in which we can do the synchronization is by adding the synchronized keyword in this particular method. So what I'll do is I'll add the synchronized keyword over here. This is simply going to make it synchronized for different threads. So just check the spelling. It has to be with the Z. And now when I actually try to run this, now you can see I always have this same consistent pattern with, 5 stars ahead and, 5 hashes after that. And every time I just run this, it's the same. And this is how, I would have a synchronized method, which is going to run for different threads, but different threads are able to only work it independently, mutually exclusive. So this is mutually exclusive for my different threads working on the same method. Now it may be possible that you don't want to synchronize an entire method. For example, after the system.out.println, I have, all other code which does not need to be synchronized. And let's say it takes, some amount of time for it to actually work in this particular area. For example, I can just introduce a Thread.Sleep and then, I can sleep it for half a second. This particular part is not actually something which I want to synchronize. So I don't want to synchronize my entire generate string. What I want to do is I just want to synchronize this, for loop or, this part of the code. So what I can actually do is I can actually add a block around it just by using these 2 curly braces and actually cut the synchronized keyword from here and put this over here. So now this becomes a synchronized block. Now this is not complete because, it's giving us an error, right? Because we really want to make sure that synchronized is for certain thing. And what is that for certain thing? We are actually going to introduce the this keyword over here for this particular object, of this worker class. So when we are actually working with the object W1, for W1, we want to add this synchronized keyword, and then every time this W1 is going to generate the string, we are actually going to have it synchronized for this particular for loop. If we have another object W2, then this is not going to be synchronized. So let me just show that. I'm formatting this and I'm running this now. Every time we have, this sequence running properly and the thread.sleep also working properly, and we have this, consistent output. But let's say I actually do not have this W1. I actually have W2. So I have actually two workers working now, and the synchronization is only for a particular object, right? So if I actually do a W2 over here, then if I try to run this, now you can see we do have this inconsistency over here. We do not have, a consistent output. And the reason for that is simple, right? We have the synchronized block only for that particular object. So if I have W1 object only working in different threads, then definitely it would be synchronized. But if I have multiple objects working with the same code, then, this is not going to work. So this is where it fails. But then if I have only W1 working, then, it would give me absolutely correct output. This is, giving me the exact correct output. I have the consistency required, and I also have, my remaining code working properly, the thread.sleep working properly, just the way I wanted. And avoiding synchronizing this entire method unnecessarily, avoiding, this whole delay unnecessarily, just because, I can actually, work with the delay, work with any other part of the code together, for both the threads. So this is the difference between synchronized method and synchronized block. Now, one recommended thing about Java is that, whenever we want to work with, this synchronized block, this object which we are wanting to synchronize it on should not be exposed to, the outside world. So if I have this class worker, I can actually have a private object, and I would call it a lock. And this is the lock, which is going to be used in place of this. So this object is also a lock, in which we actually lock this whole synchronized block. But now we are actually creating a new lock, which is called lock, and I'm just going to give a random, string to it. And this is the lock on which we want to synchronize this particular block. Now, when I actually try to run this is going to work, exactly the same way as we would expect. And when I actually do this generate string using another object, and when I try to run this works properly, consistently as well. And the reason for that is now I'm actually not dependent on the different objects which are locking this. I'm actually only dependent on this particular single lock which I created, and that is actually locking this entire synchronized block for me. So if you had, any confusion that, we might forget using the same object for locking the synchronized block, then don't worry. This is a preferred thing of Java and something which you should definitely remember when working on multiple threads and locking certain blocks, synchronizing certain blocks for access by multiple threads. Make sure that you create a private object lock and then pass that particular object in the synchronized block to make sure that, it's synchronized properly between multiple threads. Another method by which you can make sure that, even if you forget to work with, different objects, and still, the method should be synchronized, is just by making this entire method static. So for example, you do not have this synchronized lock over here, this entire, synchronized block. I'm just commenting out the irrelevant part, and I want this method to be synchronized. But I do not want to, worry about whether this method is actually being called with the same object or not. So here it's not getting called with the same object, and when I actually try to run this, I do have these inconsistencies between different threads, right? So instead of this, I would just make it static. So we would write synchronized public static void generate. And now when I actually try to run this, obviously this is going to give me warnings, just because, you know, W1 and W2 are objects and we really don't need objects to call a static method. But anyways, when I actually now run this, this is definitely going to be synchronized properly. Just because it is static, it is not dependent on a particular object lock. So even if I actually don't call it using W1, I just call it using worker.generateString and then, you know, again worker.generateString, it's going to give me a proper result. And this is how, you know, in another way, you can actually use a static synchronization method, a static method which is synchronized to be worked on by different threads without worrying about whether the lock is from the same object or not. So for now, I'll just get it back to how it was. And I can just write for your reference that we could also have a static synchronized method like so. So this is pretty much about synchronized keyword and how we could have thread synchronization.